Hi everybody, so today we're going to expand on parallelograms a little bit and we're going to talk about the more common shapes that you're used to, which are rectangles, rhombuses, and squares. So those are actually considered special parallelograms. The reason they're considered special parallelograms is because they're parallelograms, but they also contain some special properties. So a rectangle it's just a quadrilateral that has four right angles. So that's the definition of a rectangle. Okay, so the way that a rectangle looks is something that you're probably familiar with. It's just a four-sided shape, which is a quadrilateral, but all four corners have that little box, which indicates that they're right angles or 90 degrees. So that's the definition of a rectangle. All right, and then we'll expand on the properties in a little while. All right, so the next one is a rhombus. A rhombus is a quadrilateral, again, has four sides, with four congruent sides. So a lot of times you might have heard this being described as a tilted square, because a square, as you know, has four congruent sides, but it's kind of tilted. So something sort of like this. So it's got four congruent sides. So in each side, I'm just going to put one tick mark indicating that each side is the same length. So that's what a rhombus is. Okay, and then a square is if you take a rectangle and you take a rhombus and you put them together, that's what a square is. So a square is also a quadrilateral, so as we know, it has four sides with, and now this is where we take a rectangle and rhombus and merge them together. It has four right angles and four congruent sides. Okay, and then that gives us the shape that we're very familiar with, which is something like this. So it's got those four right angles. I'm going to put the four boxes. Not a great picture that I drew. So it's got the four boxes and it's got the four congruent sides. So I'm going to put a tick mark on each side. Okay, so that's what a square would look like. All right, so the next thing that I'm going to do is I'm going to do a little flow chart. So a flow chart you've probably seen before. So I'm going to start off with our flow chart with the word quadrilateral. Okay, so what do we know about a quadrilateral? A quadrilateral has four sides. So it's a polygon with four sides. Okay, those sides don't have to be congruent. Those sides don't have to be parallel. It just has four sides. Okay, so it could look like that, for example. That would be a quadrilateral. Okay, so then after we talked about what a quadrilateral is, we talked about a special type of quadrilateral, which was the parallelogram. Okay, so a parallelogram, it looked something like this. So a parallelogram has two pairs of opposite sides parallel. So it would look something like that. So I'll write down what that definition is. Two pairs of parallel sides. Okay, then we also discussed that a parallelogram has opposite sides congruent. Opposite angles are congruent. Consecutive angles are supplementary. And then the diagonals bisect each other. Okay, and then in the previous video, you can see exactly what those look like. Okay, and then what we're going to do is we're going to take a parallelogram and we're going to break it into two special types of parallelograms. So I'm going to continue our flow chart by breaking a parallelogram into two different shapes. Okay, the first shape is the rectangle. And then the next shape is a rhombus. Okay, so a rectangle, as we said, it looks something like this. And then a rhombus, we said, looks something like this. Okay, so the definitions, I'll put the definitions down for both. The definition of a rectangle is that it has 4 right angles. Now, in addition to a rectangle having 4 right angles, it has all of these properties above. Diagonals bisect each other, the consecutive sides are supplementary, the opposite angles are congruent, the opposite sides are congruent, and then it also has 2 pairs of parallel sides. So this has everything a parallelogram has, plus it has 4 right angles, and something else about the diagonals is that the diagonals are congruent. So that's what makes a rectangle special. It has 4 right angles, and the diagonals are congruent to each other. So if I measured from this corner on the bottom left to the corner at the top right, if I measured that length, and then I do the top left to the bottom right and measure that length, those lengths would be the exact same. All right, now what's special about a rhombus? Well, it has 4 congruent sides. That's the definition. And then in addition to that, if we were to draw the diagonals in a rhombus, those diagonals would be perpendicular. Which means they intersect at a right angle. So if I was to draw this diagonal, and then I was to draw this diagonal, they would intersect at a 90-degree angle, which is only true for rhombuses. Okay, and then the next special thing is that the diagonals bisect each angle. So the diagonals are perpendicular and the diagonals bisect each angle. So that's what makes a rhombus so special. Okay, now what happens next is if you actually take the rectangle and then you take the rhombus and then you merge those two properties together, you're going to get a square. Okay, so if we take the rectangle and then we take the rhombus and we merge them together, you get a square. So a square, as we said, it looks something like this. It's got 4 congruent sides, just like a rhombus does, and it's got 4 right angles, just like a rectangle does. So since it has those two properties, it makes it a rhombus and a rectangle. So a square is a rhombus and it's also a rectangle, and it's also a parallelogram, and it's also a quadrilateral. So that's how this flowchart works. So I don't have any additional properties to write about squares. Properties of squares just contain every single one in this flowchart. All right, so now let's take a look at some examples and how we can apply these different properties. So I have an example of each, so you can write these down so you have a good reference. So a rectangle, let's see, it has 4 right angles. Let's start with that. We'll go in order of the properties. So it has 4 right angles, right? Okay, so since rectangle EFGH is a rectangle, the angles add up to 90 degrees. So angle E, these two angles should add up to 90. So if angle FEJ is 65, we do 90 minus 65, and that would leave us with 25. So the angle that's missing down at that bottom corner, angle JEH, that's going to be 25 degrees. Okay, because the angles are, they should be complementary because the corners add up to 90. All right. So now let's move on to the next property of a rectangle, and that's that the diagonals are congruent. So that means that the length of EG is equal to the length of FH. So keeping that in mind, and then thinking about how a rectangle is a parallelogram, since a rectangle is a parallelogram, the diagonals bisect each other. So what that means is that EG is bisecting FH, making FJ congruent to JH. Well, since JH is 17, that means that FJ is 17. And now this is where the properties of rectangles pop in, is if this entire length is 17 plus 17, which is 34, then that means that the other diagonal is also 34, making EJ 17 and JG 17. Okay, so that's how rectangles work. All 4 of these little pieces of the diagonals should be the exact same number every single time. Okay, so now with that in mind, let's look at this triangle that was formed by the diagonals, triangle FJE. We have 2 equal sides, which means it's isosceles. Now, if it's an isosceles triangle, then the base angles should also be congruent to each other as well. So if this base angle is 65, then we know that this angle up here is 65. Okay, and then just like we did down here, if this is 65, these should add up to 90, so 90 minus 65 is 25. All right, and now the opposite angles are equal. Well, actually, the opposite angles are all 90. But if these two are 65 and 25, then these two are also going to be 65 and 25. But you want to follow the alternate interior angles. So this one's on the bottom, so the one up on the top corner here should be 25. And then this would be 65. And we could have also done that by looking at this isosceles triangle up here. Since this side is 17 and this side is 17, then these two base angles are equal, so 25 and 25. And then 90 minus 25 is 65. And then same thing over here. In the end, if these two are 17, then these two should be equal, so this angle here is 65 degrees. And then if these two sides are congruent, then these two angles should be congruent, so this angle over here is 25. And if you added all these angles together, we would get 360. All right, lastly, we can get all these angles on the inside because we know that the angles inside of every triangle should add up to 180. So 180 minus 65, that would leave us with 50. And we can do that for all of them, or we can recognize the vertical angles are equal. So 50, so then the vertical angle would also be 50. And then we have linear pairs. 180 minus 50 is 130. So then the angle down here is also 130. So we got all the angles just by knowing one of them. All right, and then we'll just finish it off by applying the properties of parallelograms that the opposite sides are equal. So if this side is 10, then the opposite side is 10, so GH is 10. And if the top is 24, then the bottom is 24. and that's just a general property of every parallelogram. Okay, so that's everything for a rectangle. Now a rhombus. So in a rhombus, we know that all the sides are congruent. We'll start with that. So if side AB is 14, then all the other three sides are also going to be 14 inches. So BC is 14, DC is 14 inches, and then AD is also 14 inches. So that took care of that. The next thing with a rhombus is the diagonals are perpendicular. So what that means is that all the angles on the inside, on the intersection, are 90 degrees. So you can write the number 90 degrees, or you can just put the boxes. I like to put the number because now look, we have a triangle down here. We have a 90 and a 60. We know that all three angles should add up to 180. So 180 minus 90 minus 60 gives us 30. All right. Now the next part, let's look at the third property of a rhombus, and that's that the diagonals bisect each angle. So that means that this diagonal DB is cutting this angle in half, so each of these should be the same. So if this angle right here is 60 degrees, the angle above it's also 60 degrees. And then if this angle here is 30, the angle right above it's also going to be 30. And then, since a rhombus is a parallelogram, the opposite angles are congruent. So if these two are 60, then the two up at the top right are also 60. And if the two at the bottom right are 30, then the two at the top left are also 30. Okay, so we have all the angles. And now let's think about, since it's a parallelogram, the diagonals bisect each other. So if AE is 10, then EC should also be 10 inches. And then since EB is 7 inches, that means that DE is also 7 inches. Which means that the length of DB is 14 because 7 plus 7 is 14, and then AC is 20 because 10 plus 10 is 20. So we got everything there. All right, and now the square is the best because notice how they don't give you any angle measures, but technically, if we take all the properties we know and apply them, we're going to actually know every single angle measure in a square. So since a square is a rectangle, that means that each corner is 90. But since a square is also a rhombus, it means that the diagonals are bisecting the angles. So if 90 is being bisected, 90 divided by 2 is 45. So each of these is 45 degrees. So we were able to figure that out just by understanding the properties. So same thing down here. The whole thing's 90. Since a square is a rhombus, it's being bisected, so these are each 45. And that applies to all four corners. And then also, since a square is a rhombus, the diagonals are perpendicular. So all four angles in the intersection here are also going to be 90 degrees. So we just figured out every single angle without being given any. All right, now a square is a rhombus again. So if one of the sides is 7, then all of the other three sides are 7. And then since a square is a rectangle and a rhombus and a parallelogram, the diagonals bisect each other. So if AX is 5, then ZA is 5 inches. And then if this whole thing is 10, so ZX is 10, the diagonals are congruent because a square is a rectangle. So that means that WY is also 10. So that means WA is going to be 5 and AY is also 5. Okay, so there's a lot of properties going on here. But notice how symmetrical a square is. Remember when we talked about the word regular? A square is a regular quadrilateral, which means all the angles are equal, all the sides are equal, and that's why everything looks so symmetrical. If you were to fold a diagonal, or if you were to fold a square vertically, everything would match up. Horizontally, everything would match up. Diagonally, everything would match up. So a square is a regular shape. In this final part, I'm going to show you how to apply a little bit of algebra. So in this picture, let's call this shape rhombus EFGH. Okay, so if you want to copy this picture down, just pause it. and then you can copy the picture down. And then I'm going to go through how to solve for each variable. So if we wanted to solve for each variable, let's start with x. So the way that we're going to solve for x is, since it's a rhombus, we know all the sides are equal. So side EH is congruent to side HG, is congruent to side FG, which is congruent to side EF. And that's just because it's a rhombus, all the sides are equal. So since these two sides are equal to each other, we're going to set 9x minus 11 equal to 4x plus 7. And then you would just solve that equation as you normally do. And I get 3.6. All right, so that's how to solve for x. All right, now in the picture, I see the y. So since this is a rhombus, the diagonals are perpendicular to each other, which means that every single angle on the intersection is 90 degrees. So all four of these are 90, so that means that the 2y plus 10 must be equal to 90. So that's our setup for that one. So we're going to solve this equation, and we get y is 40. All right, the next one that I'm going to solve for is z. So in a rhombus, or just actually for that matter, every single type of parallelogram, the diagonals bisect each other. So that means that EG is bisecting FH. So that means that HI would be congruent to IF. So these two pieces are going to be equal. The 7x plus 2 is going to be equal to the 4z plus 15. So solve this equation. And you should get 4.3 repeating. Okay, so that's that equation. All right, and the last one is, again, that the diagonals bisect each other. So that means that HF is also bisecting EG. So EI is going to be congruent to IG. So we're going to set those two expressions equal to each other. So 5a is equal to 3a plus 17. So solve this equation. And we get 8.5. All right, so now that we have all of our variables, we can go back and plug them all in and figure out what the actual lengths are. So we figured out that A was equal to 8.5. So now if we want to find some of these lengths, we can plug A in. So 5 times 8.5, that's going to give us 42.5. So EI is 42.5, which means that IG should also be 42.5. So if you plug A in here, you'll also get 42.5. We found that Z was 4.3 repeating. So if we plug that in here, 7 times 4.3 repeating, and then plus 2, we get 32.3 repeating. And that means that IF would be the same length. So 42, 32 and 1/3. X, let's take our value of X. X was 3.6. So I'm going to pick, how about this one? That looks easy. So 4 times 3.6, and then plus 7, you get 21.4, which means all four sides should be 21.4. even the ones that didn't have expressions. All right, and then lastly, they told us that we found that y was 40. So since y is 40, we plug it in here and we'll get 90. And also down here, this is going to be 40 also. Because if y is 40, then this angle is y, so this angle would also be 40 degrees. And then since the diagonals bisect each angle, the angle above it's 40 degrees. And then opposite angles are congruent, so the other two angles at the top left are 40 degrees. And then to find the other angles, we have 90 and 40, so 180 minus 90 minus 40, that leaves us with 50 degrees. So all the other angles are 50 degrees. So then this entire angle up here is 100 degrees. This entire angle up here is 80 degrees. This angle down here is 100 degrees, and then this angle at the bottom right is also 80. Okay, so that's how we can apply algebra to these questions. All right, so that's all for this lesson. Have a great day.